So 4.2 is all about word problems involving these quadratic functions that we saw yesterday, and we're going to talk specifically about questions that involve finding maximums or minimums. Now, how do we do that? Well, remember what a maximum and a minimum looks like on a quadratic. In a quadratic function, a quadratic, graphically, produces parabolas. Now, a parabola looks like this U-shaped function here. You can have an upwards parabola or a downwards parabola. And we saw yesterday that no matter if you have an upwards or downwards parabola, there's a special point that we call the vertex. Well, the idea is that the vertex will always carry the function's maximum or minimum. In the left example, if we have an upwards parabola, we can say that the vertex is on the bottom. So this right here is also a minimum. And if the parabola opens downwards, this is a maximum. Now let's refresh our memories on when we will get a max or a min. We will get a minimum or an upwards parabola if the x squared coefficient is positive. And we'll get a maximum or an upside down parabola if the x squared coefficient is negative. So the idea is, if we can find a vertex, then we should be able to find a quadratic's maxes and mins. Let's refresh our memories on how to find the vertices, the vertex. Well, finding the vertex will all depend on what format the equation is. So if we had standard form, which is y equals ax squared plus bx plus c, we have a straightforward formula to find the vertex. The formula was that the x-coordinate of the vertex was negative b over 2a. If we had vertex form, which is y equals a times x minus h squared plus k. You can tell vertex form because it almost always has a parenthesis squared. Here you don't need any fancy formulas. You just read what the vertex is. So the vertex will always be located at h comma k. And the idea was that this h here and this h would always be opposites of each other. And if you had intercept form or root form, also known as factored form, so y equals a x minus p times x minus q here, the x-coordinate of the vertex would be the averages of the x-intercepts. So that would be x-intercept number 1 plus x-intercept number 2 all over 2. Now, with standard form and intercept form, I only show the formulas to find the x-coordinate of the vertex. I hope everyone understands that to find the y value, you just plug it in. So finding the vertices, finding the vertex, finding the max and min should not be the hard part. The hard part about this section is, can we read sentences? Can we read a paragraph and build a function? Now, there are a bajillion different types of quadratic example types out there. It's impossible for me to go through every single type, but these are a couple of the more common ones. When you do your practice, just plug it along. Try your best. The only way you can get better at word problems is if you practice. So let's read the first example here. The first example says, a go-kart track has about 380 racers per week and charges each racer $35 to race. The owner estimates that there will be 20 more racers per week for every $1 reduction in price per racer. At what price should the owner charge to maximize weekly revenue? So I think the key word here is revenue. So you can't really do this problem unless you know what revenue is. So if you don't know what revenue is, here it is. The idea of revenue, at least in the context of these quadratic problems, is price times the number of customers or objects or items. Depending on what the context of the story is, you might be selling objects instead of charging people admission. So it'd be price times the number of items you sell, so on and so forth. So in this particular case, I know because we're talking about revenue, I'm probably going to take the price and multiply it by the number of customers. Now, if we just skim the problem, it seems like they give us all the information we need, right? What do they say here? This owner charges $35 to race. Well, clearly that's what he's charging. So here's my price. There are 380 racers per week. Clearly that's the number of customers, number of people. Right. But he also says stuff like this. There'll be 20 more racers, $1 reduction. So this isn't going to be a simple formula as 380 times 35 because we're going to be changing the price and we're going to be changing the number of racers. So what you have to do is use a variable, say x, to accommodate or to represent these changes. So let's go ahead and build our function here, right? So I'll use r instead of f, r for revenue. Our revenue function should equal price. So what is our price here? Well, clearly, according to the problem, it's $35. But according to the problem, what are we doing to the price? We are doing a $1 reduction. So this price of $35, I'm actually going to subtract $1. But I don't know how many times I'm going to reduce the price. I could reduce it 1 time, I could reduce it 2 times, I could reduce it 5 times. So because I don't know the number of times I'm going to reduce it, that's going to have our variable attached to it. So I hope everyone can agree or just understand that this whole guy here represents our new price. This is the old price minus $1 reduction every time. Now I don't know how many times we're reducing, so hence the variable. Now what we need to do is multiply this guy by the number of customers. Well, according to the problem, we have 380 customers. But every single time we reduce the price, what should happen? According to the story, 20 more racers per week. So when there's 20 more, that's adding. So I'm adding 20 more racers. But again, how many times are we reducing the price? Are we reducing the price 1 time? So there's 20. Are we reducing the price 2 times? So there's 40. We don't know. So it has to have a variable attached to it. There we have our function. Now we have our revenue function, and according to the problem, what is it that I want to do with the revenue? And it's in the last three words here. I want to maximize my revenue, and that's the key word in all these problems. If you hear the story asking maximum, minimum, immediately in your minds you should be thinking of vertex. Well, okay, I need to find the vertex here. Well, I look at the equation that we built and I ask myself, what form is he in? So hopefully we can just look at the 3 forms here. We have standard form, we have vertex form, we have intercept form. This is the equation that we have. These are the 3 forms. Which one doesn't match? I hope we all can see that it matches the intercept form or the factored form. So this equation here is factored form, and then to find the vertex, I need to find the x-intercepts and take the average. Now I know yesterday we said, oh, the x-intercept, it's just the opposites of these numbers. But that was for simple, easy functions. These functions are a little bit more complicated. So here's the cool trick, or not trick, but here's the idea of finding the x-intercept. You take each separate parentheses and separately set them equal to 0. So this guy here, 35 minus x, I'll set him equal to 0. And this guy here, 380 plus 20x, I'll set them equal to 0, and then you solve. So if I solve for x by, let's do the left equation. If I solve for x by adding x to both sides, I get 35 equals x. And then let's go ahead and solve the right equation. I'm going to subtract the 380. So that gives us 20x equals negative 380. and then divide out the 20. That gives us a negative, what, 380 over 20 is a negative 19. Now we got two answers here, but it can't be two answers. Only one answer should make sense. Well, actually, we actually want both of them because we need to find the average. So I know that the x-intercept, or excuse me, the x-coordinate of the vertex will be the average of these guys. Add them up and divide by 2. That's going to give us 8. Now you have to be very careful about what it is that the function that the question is actually asking you to solve for. Sometimes they're asking you to solve for the x value, and then you could stop here. Sometimes they're asking for the y value. You just need to read the question. Notice it says, at what price should the owner charge? Now, of this problem here, of this equation, here's the equation that we built. What part stood for the price? I hope we all remember that this guy here stands for the price. So for this particular problem, it doesn't want the x-coordinate of the vertex. It doesn't want the y-coordinate of the vertex. It just wants the entire price, which is the parentheses that I highlighted. So now that I solve for x, notice how the parentheses that I highlighted, our answer, our price here, has an x. Just plug it in. Okay. So if I plug it in, 35 minus 1 times 8, that gives us a 27. So the owner should charge $27. Now, if I wanted to know how much money he would make, I would take the 8 here and plug into both of the x's. But it didn't ask for total money. It just asked for what he should charge. So there are a lot of variations to this question. I could ask you for the price. I could ask you the maximum revenue. I could ask you how many customers would come in. You just have to read the story and understand what parts of the question they're asking you. Let's take a look at a different example here. So this example here says a rocket carrying fireworks is launched from a hill 80 feet above the lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height in feet above the surface of the lake is given by this function here. So this is actually nice. They did the hard work for us. They gave us the formula, or the function, where t is seconds after launch. What is the maximum? There's the key word there. What is the maximum height reached by the rocket? So before I even do any thinking, the fact that I read the word maximum and the fact that the equation that they gave me is a quadratic, I know this is a vertex problem. Now, what does this equation tell us? It tells us the height after t seconds. So h stands for height, and the variable t stands for time. Now notice it says maximum height. So ask yourself, is it looking for the x value or the y value of the vertex? Since the height here is h of t, since height is the output of the equation, clearly I know it's looking for the y value. So when I do my work, I'm not going to stop at the x-coordinate of the vertex, I'm going to stop at the y-coordinate. So the x-coordinate or the t-coordinate of the vertex, because I know that this is standard form, is negative b over 2a, which in this example is negative 64 over negative 16. So if I divide negative 64 by negative 16, that gives me a 4 seconds. Now again, if it said how long do we have to wait until it hits the maximum, that would be our answer. But it didn't say how long, it said what the actual maximum height is. So I'd need to take this guy and plug him back into the function. So what is h of 4? Negative 16 times 4 squared plus 64 times 4 plus 80. And all you got to do is just do the math. Negative 16 times 4 squared plus 64 times 4 plus 80 is 80. So the maximum height is 80 feet. So that's basically the idea of these types of problems, right? If the word problem involves maximum or minimums. You know it's going to be a vertex question. Now, the second thing you have to do is figure out what form of quadratic they give is the problem. If they give you the equation, well, that's easy. Just follow whatever they give you. But if they don't give the equation, you have to build it. Sometimes it might be a vertex form. It might be intercept form. It might be standard form. And then after that, after you figure out what form it is, you got to figure out what the heck they want. Do they want the x value? Do they want the y value? Maybe they want both, or maybe they just want part of the equation. So, I mean, this is sort of the nice thing about it. Max and mins are always vertex problems, but the hard part is we need to read the question carefully to know what part they're looking for. And the only way we can get better at this, again, is to practice. So good luck.